Good morning to all participants. Welcome to the first sessions of the day 4 of the Data and Computational Journalism Conference Indonesia, or DCJ CI 2022. And thank you for joining with us in today's workshop, where we learn a lot about machine learning in the newsrooms. And this workshop will be divided by 3 sessions. First, a presentations from our speaker. Second, the demo part. And the last one, it will be like the questions and answer sessions. And my name is Utami Dyah, and I will be the moderator for these sessions. A bit about my background: I'm currently working as a lecturer of data-driven storytelling at Universitas Multimedia Nusantara. I pursued my master's degree in data visualizations and data journalism at the University of Nebraska-Lincoln and had my professional certificate in computational journalism at Columbia University. Our workshop for today will be taught by Jonathan Soma, who is a professor at Columbia University Graduate School of Journalism, where Soma directs the full-time data journalism program as well as the LEDE program summer intensive. At LEDE program, he taught investigative journalists around the world to learn about coding, interactivity, and machine learning. He is also a programmer and educator who focuses on making an approachable data and concepts accessible. Morning, Soma. How are you doing?
I'm doing great. Good morning to you. For me, it's 10 p.m. right now, but so I have a little bit of a good evening, I guess.
Good evening.
I'm excited. I'm ready to go.
In New York, yeah? New York time.
Yes.
Right.
So fun.
Okay, so shall we start the presentation?
Let's start. Let's do it.
Okay, so floor is yours. Go ahead.
All right, perfect. So I just shared a screen. Does that work? Are we good? Are we perfect?
Yes, it's perfect.
All right, excellent. So if you would like to, follow along with the things we're doing, I have a lot of links. I have some programming stuff and all of that at the link that I put there. If you want to contact me, there's my contact info. And as you all know, today we are going to be talking about machine learning for newsrooms. Is it the most exciting thing? Possibly, potentially. So when people talk about machine learning, when people want to learn machine learning, the way that I learned machine learning is I just thought, oh, this seems interesting. I should probably learn it. It seems like it's fun. That's not the approach that I take when I'm dealing with journalists, when I'm teaching journalists, because there's so many different aspects to machine learning that you really want to focus on why you are learning it. I'm going to focus a lot on the tasks that you will do using machine learning, not so much theory. Even though, yes, I do have a computer science background, all of that computer science stuff is boring compared to all of the exciting stuff that journalism is. So when we talk about machine learning, we talk about a lot of different things. And mostly this is just, there are a lot of synonyms for machine learning. So ML, machine learning, obviously. You could also refer to machine learning as artificial intelligence. These two terms pretty much mean the same thing. Someone who talks about artificial intelligence maybe is trying to make machine learning seem very fancy, very complicated. Oftentimes, new techniques start out as artificial intelligence, and then once people get kind of bored of them or used to them, they start to call them machine learning. If you are a statistics person, whether you love statistics or hate statistics, most of machine learning is just built on statistics. So a lot of people say that data science or machine learning is just taking statisticians and giving them a fancier title. Even non-fancy statistics kind of falls under the banner of machine learning. We're going to be doing a little bit of linear regression today, which is probably the most basic kind of statistics that exists, but it can also accomplish a lot of very exciting things in the world of journalism, in the world of machine learning. So if someone tells you something is machine learning, just agree with them. Just say, that sounds great. That sounds like machine learning. Delightful. Now, in the newsroom, there are two big groups that will use machine learning. Yes, there might be a few other directions that machine learning might be used, but two main ones. On the one hand, you have people on the business side of the newsroom. They might use machine learning to increase conversion rates, the number of people who visit your homepage, who sign up for a newsletter, or the number of people who see a tweet and then click it. They're trying to optimize those numbers. Additionally, maybe something like article summaries, where you have machine learning read an entire article and then write the short blurb that shows up on the homepage. Additionally, if you're very fancy, if you're like Reuters or Bloomberg, you have whole teams that take in tons and tons of data and just turn that data directly into stories that get published. So you don't even need a human being in the loop. It's just a computer reads a data set and it writes a story about it. I'm not really excited by that stuff, and I don't think it's as useful for what I'm interested in. I love the investigative side of things. So we'll use machine learning in this talk to uncover unusual data points, to kind of dig deeper into a data set to say, what is strange here? What are outliers that we can inspect? Finding bias. So this probably 75% of machine learning stories in the US are about bias, about racial bias or gender discrimination, and different ways that you can look at systems that exist in the world, whether they are a system created by people or a system that is created by computers, and then see, are they biased in one way or the other? And then the one my students love the most, which is doing a lot of work very quickly and easily with you not having to do anything. So do you want to read 100,000 articles or 10,000 tweets or 1 million proposed pieces of legislation? Probably not. And machine learning can come in handy because you can just take the computer and say, computer, read these for me, and it'll do it. So the way that machine learning works, I don't care about. You don't need to care about it either. All you need to know is the machine is just a black box that sits in the middle. We feed some information into this black box and something comes out of the other side. That's it. I don't care about the stats inside, the math inside, the computation inside. I've studied all of these things, but I don't think they're actually important. The reason why they're not important is because we're journalists. We're not doing research as computer scientists. We are trying to develop stories and use machine learning to an end, not to just explore the scientific practice of what machine learning is. Now, to give you an example of how this works, I created a website called investigate.ai. And what investigate.ai is I took all sorts of machine learning techniques that have been used in newsrooms and just put them on the same website. So stories from all over the United States and Europe about everything from, I don't know, there's all kinds of things in there. We'll go over a few later. And it is focused on the things that are important to you as opposed to the things that are important to computer scientists. So it's what you need in order to accomplish your task, not theory. Because you're a journalist, you're not a statistician, you're not a data scientist. What you need to be able to do is use machine learning to generate leads for stories. If you are a statistician, if you're a data scientist, let's say you're working on the homepage of your newspaper and you want people to sign up for the newsletter. It's the most important thing ever. You're going to tweak whatever you can to get people to click that little button to sign up for the newsletter. And if the number of subscriptions goes up, you're going to be happy. On the other hand, if you're a journalist, you're going to treat everything that the machine tells you as a suggestion, not as a fact. If I showed up to you one day and I said, I have news for you. Amazon.com has developed an army and they're going to invade Australia. You would say, I mean, that sounds interesting, but I don't know if it's true. And then you would do a little bit more investigation to say, no, it turns out that I'm actually not telling you the truth. It's the same thing with machine learning. Even if the machine tells you something might be true, as a journalist, you're going to be mostly focused on proving whether it is or not. And so when we're talking about this, something comes into the machine, something comes out of the machine. Let me give you an example. What machine learning is the practice of you saying, here are a bunch of examples, figure out how everything is connected. Let's say I run a coffee shop. I sell coffee at my coffee shop. I sell 3 cups of coffee, and then there's a little bit of a tip, and I make $7, or $7 goes into the register. Then another example is 3 cups of coffee get sold and a donut gets sold, and that costs $12. And then 1 cup of coffee is sold and 2 donuts are sold, and then I make $15 after tip. And the question that you would ask the machine is, how much is usually a cup of coffee, or how much is a donut? Because maybe they're not always the same price. And this is all machine learning is. Machine learning is simply the practice of you giving all of these examples to the machine, and the machine figures out the connection and says, you know, I think that maybe the coffee is around $2 and maybe the donut is $4 or $5. So if you want to get rich, sell a lot of donuts as opposed to coffee. This practice is called training a model. Training is the act of showing examples to the machine that the machine can use to learn, you know, what's going on in the world. The model is the thing that comes out of it. It's that black box. Once you have taught the machine everything about coffee and donuts, it now has a model of the way that coffee and donuts are sold in our cafe. You can think of this as if you made a little model car, or if you had like a model of a building. It's not the same thing as the car. It's not the same thing as a building. It's kind of a simplified version. It's a smaller version that's easier to deal with. Now, I could teach you how to do machine learning in a million different ways, 2 million different ways. We could use thousands and millions and infinite numbers of tools, but that's not really what's important. What's important here is how you use the tools, not which tools you use. So for example, I hang out on Twitter a lot, and the most popular thing on Twitter for the past few months has been Dolly and Midjourney and other different tools where if you give it a prompt, it just draws a picture for you. So for example, you can say, add together a durian and an orange, and it will give you a durian that has an orange inside. You can say, get rid of this street, replace it with somewhere people can walk, and it will do that. Some people might say, oh, this is just a machine learning tool that you didn't develop. You didn't create it. You don't know how it works. All you're doing is typing something in and getting a result. I don't care. If that's all you need in order to make a design to show, here's what this city might look like if it had flowers and walkable paths instead of streets, that's perfectly fine. Some people might be dissatisfied with that though. You say, I'm very technical. I want a program. It's going to be great. You can do that too. If you want to start from the very, very basics, the foundations of machine learning, there are all sorts of programming tools for that too. Scikit-learn, TensorFlow, it goes on and on. They also change and adjust all of the time. For example, the tools that I'm going to show you today are based on Scikit-learn, sklearn on this slide. It is a more traditional kind of machine learning that I think is better for journalists because it's easy to say, hey, Scikit-learn, why did you make that decision? Please explain yourself to me. And it'll say, here's why I made the decision. Whereas for more complicated systems that involve more artificial intelligence kinds of tools, neural networks, things like that, it's a little bit harder to understand why they're making the decisions that they're making. And I think that that's the kind of thing that's important to know as a journalist. There are also a lot of tools that kind of fall in between, such as Kern.ai's Refinery or Google's Vertex.ai. And I don't really like to recommend these tools, even though they're easy to use. The reason is they change all the time. Maybe they're free for a little while, then they stop being free. For example, I went to go create a project for you all to go through on Google's AI platform. And when I started to sign up for it again, I realized they had just gotten rid of the old one, put a new one in its place, and the new one is completely different. The documentation is hard to use. None of the skills that you brought from the older version of their AI platform transfer to the new one. And Google loves to disconnect things all the time, so I just figured it's fine. We're going to do this in the very technical way, but I promise, even though it seems technical, it's very, very simple. It's just a few steps. Now, there is a warning I need to give you, and that warning is if we are taking a machine and we're saying, here are a lot of examples of how things are, please learn about them. When we ask for output from the machine, it only understands what it's already seen. The machine learning model that we create is just a reflection of the same things that we give it. One of the reasons why I think it's very, very useful for journalists to learn machine learning is not to use it in investigations, but to be able to speak and understand more intelligently about machine learning in the wider world. Things like facial recognition, text analysis, all of these things. By knowing even a little bit of how to use these tools, you're better able to understand some of the downsides and gotchas that go into them. For example, Amazon, everyone's favorite machine learning organization, they said, you know what? A lot of people apply to work at Amazon. So what we want to do is build a system that will automatically screen resumes. We'll look at examples of everyone we've hired before and their resumes and use that to teach a machine what kind of people we like to hire. So when someone submits a resume, the machine can look at it and say, you seem like someone we would hire, or no, let's not interview this person. They don't seem like someone we should hire. It turned out that the kind of people that don't get hired by Amazon are women. So when interviewing for technical positions, what would happen is the machine would notice on the resume something like, I was playing women's volleyball, or I went to a women's college, or I did gender studies, or I was on the women's chess club. And based on what it had seen before, it said, oh, people that, played on the women's volleyball team, or people who played on the women's chess team, or all of these things, didn't end up getting hired from us previously. So let's just continue to say, no, we should not interview these people. Luckily, they figured this out before they actually started to use the system, but it's scary that it got so far that there are pieces all over the internet about it. This is the same thing with something like predictive policing, where this is a popular thing, or was a popular thing in New York. They're trying to bring it back. It's the idea that if you look at where arrests have been made previously, you know where to send police because they know that those are the dangerous areas. But it turns out the reason why there are so many arrests in those areas is because the police went there in the first place, maybe looking for trouble, who knows? And so it's difficult to kind of untangle, should you send more police there, or are you just reinforcing something that was already there as a system? Additionally, when we're thinking about what we're using to train our data set, for example, as we saw before, we trained a model based on coffee and donuts being sold at my cafe. But what if I started selling sandwiches and salads? And someone buys a lot of sandwiches, someone buys a lot of salads. The machine doesn't know what to do with that. The model says, I've never seen these things before, so I don't know, I guess they're free. Who knows? Now, this becomes an issue with something like facial recognition, where a lot of the data that's used to train facial recognition systems is white men. And so if you show people who are darker skinned, or if you show women, the machine says, I don't really know the difference between all of these people because I'm only really good at discerning white guys from one another. So thinking about the kind of data that you're feeding your machine is also super, super important. And unfortunately, this also bleeds into when you're using tools. So when we're thinking about using those tools like DALL-E or Midjourney or other tools where you just say, here's some information, give me something back. Here's some text, draw me a picture, right? Sentiment analysis is some of my students' favorite things to do when it comes to machine learning. They say, I'm going to scrape 1,000 tweets from Twitter and figure out whether people like something or don't like something. And they don't know how to write a sentiment analysis machine to know whether something is positive or negative, so they just download one. Seems perfect. Everyone loves to do this, but there's a problem. So what we're looking at right now on the screen is 8 different sentences, and 3 different sentiment analysis tools that are all saying whether these are positive or negative. So one is positive, negative one is negative, and they just can't agree. And the reason why is because every single one of these sentiment analysis tools was trained on a different data set to learn what is positive and what is negative. So for example, this first one, text blob on the left-hand side, it just read a bunch of reviews from Amazon, and it took out a lot of words. And then someone said, hey, based on these words of product reviews, is this word positive? Is this word negative? And like a million people said, this word's positive, this word's negative, this word's positive, this word's negative. And as a result of people ranking all of those words, it counts up the positive words, counts up the negative words, and then tells you whether it's positive or negative. Whereas the one in the middle is a little different. It read movie reviews instead of product reviews. So the kinds of language that it understands is more related to movies than products. The one on the right-hand side, they just came up with a list of random words and then had people rank whether they're positive or negative words. So because all of these came from different places, they have different outputs. Now, as I've said before, we're journalists, right? So we're not going to say, I looked at a sentiment analysis machine and it said this is positive, so it's positive. Or I looked at, text blob and I said, is this sentence negative? And it said, yes, it's negative. We're only using this for investigation as a beginning to do research, because things can get a little tricky. BuzzFeed in 2017 came out with a piece where they trained a computer to search for hidden spy planes. They saw some planes that were flying around, I think the San Francisco Bay Area and New York City, and they said, okay, I know that these planes that are flying in circles are from the government. They're from the FBI, they're from the Department of Homeland Security, and they're looking for people or looking at people. Said there's probably other planes that are out there that are flying around in circles that are secretly belonging to the FBI or secretly belonging to the Department of Homeland Security. So what they did was they took a machine and they fed it a bunch of examples of what normal planes look like and what surveillance planes look like. And then from the other side, they could point this model at a plane and say, is this flying in the way that a spy plane flies, or is it flying like a normal plane? And so they can test it. They can say, all right, we have some planes that are not surveillance planes. And it turns out we predicted accurately 120 of them, and 4 of them we didn't. And just there are all these different ways you can kind of say this worked well, this didn't, this did, this didn't. But to me, this thing, a confusion matrix, not important at all. What I want to think about is, if we are wrong, what goes wrong? If we inaccurately say this is a surveillance plane and it actually isn't, what's the downside of that? In this case, it's just someone has to do more research work, right? All we're doing is saying, here are a bunch of planes, here are the most likely surveillance planes, go through the list and look at them. Maybe we give it to an intern, right? So if one of them is maybe a surveillance plane, maybe not, the intern looks at it and says, oh, not a surveillance plane, and it's fine. No one cares after that. But if you're the LA Times and you write a classifier that looks at crimes, and it looks at the crimes and says, this crime seems like a violent crime, this crime seems like a not violent crime, and it does an analysis, and then you run the analysis through and you say, based on our model, there are 1,200 crimes that should have been violent crimes that the LAPD downgraded into minor offenses. When you start making statements like that, you better really trust what's going on inside of your model, because otherwise, probably the LAPD is going to get angry at you and start making some noise and stop fulfilling your FOIA requests in order to give you this data. So now that I've told you a lot about how I don't care about how machine learning works, and I've told you to be really scared about the kinds of things that go into machine learning, let's make some projects. We're going to make 3 different projects. We're going to do a linear regression project, we're going to do a logistic regression project, and we're going to do a classification project. So all of these projects are published projects that exist in the world, and they also exist on my investigate.ai website. The first thing we're going to do is we're going to use linear regression to find unusual data points. So you might be in a situation where you have, I'm just going to give you the example we're going to use. We have a bunch of test scores from a school, and we say some of these schools might have cheated. How are we going to figure out whether these schools have cheated? So what we're going to do is we're going to collect data on all of these schools. In this case, we're going to collect their test scores from 2003 and their test scores in 2004. We're going to say, based on how schools usually operate, if we look at their 2003 scores, we can predict their 2004 scores. If you usually do a good job at tests, you're still going to do a good job at tests, right? But in this case, we're going to say, were there schools who did very, very poorly in 2003, but then very, very well in 2004? Because if so, it might be time to do a little bit of investigating. So let me stop sharing for a second. I am going to pop open our website that we are going to use and share that one for you. All right, so here is our GitHub repository here that has all of our information in it. I have a link up at the...
Sorry to interrupt. Can you share the link of the GitHub in the chat?
Oh, yes, absolutely. Yeah? I can throw that in the chat.
Okay.
All right, I have tossed it on in there. And I also have the presentation in a few situations. Also here, so we're going to be doing outliers with linear regression, then bias with logistic regression, then classification. So as we go through here, in each section, I have a couple examples of a story that uses this tool. So this is 2 examples of linear regression. This is 3 examples of logistic regression. And then this is 3 examples of classification. For almost all of them, I have a link to my write-up on investigate.ai, where you can reproduce it on your own, and additionally, the actual piece that was written. So you can see the original piece, you can see my code where I've reproduced it. So for us, we are going to, I'm going to click, okay, when we want to run this code, we can run the code. You can download it yourself if you're familiar with Jupyter Notebooks. The notebooks are inside of here. If you're not, we have 2 different options. One option is you can click Read Notebook on GitHub, and then you can just read through all the stuff that I'm going to talk you through. You can open up the links. You can do, you know, whatever is right to you. If you want to actually run the code and maybe tweak it for yourself, you can click this other link that says Run Notebook on Google Colab. So that's what I'm going to do. Google Colab is a way that you can run code on Google servers instead of on your computer. It's really, really common for machine learning people to use these sorts of tools because the machines that Google will give you are more powerful than the machines that that your computer is made up of. Why did they give you these for free? I don't know the answer. It's not suspicious, but who knows? Who knows? So what we're going to do is we're going to reproduce this story right here, where TAX is a standardized test that students in Texas had to take every year. And the question is, can we find students, or can we find schools where their scores are very different between different years? So the way that Google Colab works is you are going to hold down Shift and you are going to push Enter. And that is going to move you up and down between all of these bits of code. You're going to get a warning, and it's going to say, this notebook was not written by Google. Who knows what's going on? And I say, you can trust me. We're going to run it anyway. The first thing that's going to happen, if you didn't download this to your own computer, is I'm going to download the 2 data sets into Google Colab. If in the future you try to do linear regression or logistic regression or classification using one of my notebooks here, some of my example code, you can upload your own data by clicking on the left-hand side where it says Files, and then just clicking this Upload button right here. But I didn't want you to have to do that for this. This code right here will automatically download the files for us. So I'm just going to delete these little comments here, Shift Enter, and it will download those two data sets for us. This right here is a school. Each row is a school. That's its code, its campus code. This is the name of the school, Cayuga Elementary School, and this is its reading score in 2003. Now, just having it score in 2003 is not going to be very useful. We want to be able to compare it to the score in 2004. So this is our other data set here, where it's that same campus number, it's the school's code, along with the score from 2004. I'm going to combine those together to have a delightful, perfect, finished data set that is the campus code, the name of the school, how they did in 2003, and how they did in 2004. Now, a lot of times when you're looking at a data set, the way to know whether you want to use linear regression is when you start using the word correlation. My students love to do this. They say, I'm interested in if there's a correlation between this thing and this other thing, whether there's a correlation in poverty and test scores. Now, you're not actually interested in correlation. Correlation is just this boring number right here that says whether something might be related or not. In this case, it says that there is a 0.8 correlation between the reading score in 2004 and the reading score in 2003. That just means, yes, there's some sort of connection there, but you're never going to publish this in an article. It's never going to happen. Doing correlations, it's not actually useful for you as a journalist. What we want to do is our good friend linear regression. So the way we're going to do linear regression is, first, not every school existed in 2003. Not every school existed in 2004. For any school that's missing a score in 2003 or 2004, we're just going to throw it out the window. We're going to get rid of it because it doesn't make sense to predict how a school did in 2004 if we don't have a 2003 score. So now we're down to about 3,500 schools. So we only lost about 54 schools, not that big of a deal. So in order to run our regression, in order to build our regression model, this is all of the code that we need. This is it. We read in our data and I say, hey, I want to use the stats models library. I'm going to run an ordinary least squares regression. What's that mean? Who cares? Doesn't matter. Just know that this is the code that you run. And what this code is going to do is it's going to say, based on the reading score in 2003, can we predict the reading score in 2004? If you have a data set that you're reading in yourself, you would just change these to match your column names. So if I was doing, like I said, I was talking about my students, they're interested in the relationship between poverty and test scores, I might say the percent of students getting free lunch or the percent of students in poverty. How does that relate to the reading score in 2004? So I'm going to Shift Enter here. If you do this on your own computer, it's going to look way more attractive than the output that comes here from the in Google Colab. I'm going to be honest with you. I don't care about any of these numbers. I care about none of them. If you're a stats person or you're talking to a stats person, you might start talking about R squared or adjusted R squared. But for us, this is not what we're interested in. We're just saying, hey, learn about the connection between 2003 scores and 2004's scores. That's it. And then we have a model. How delightful, right? So what we're going to do with this model, we saved it as results, and we're going to say, look, I want you to go through our data, and based on the 2003 scores, please predict the 2004 scores. It's just that easy. Based on how it looked in 2003, what should it be in 2004? So our good friend Cayuga Elementary School, the predicted score based on their 2003 score for 2004 was 2,285. Their actual score was a little bit higher. It was 2,392. Now, if there's a difference between those two, does that mean they cheated? No, it doesn't mean they cheated. It, maybe the school districts changed, so new people went to the school, or maybe that's just a normal amount for it to go up and down. So let's keep running our code here. Let's find which schools had the largest difference between their predicted score and their actual score. So if you look at this school right here, San Marcos Prep, they scored 200 points. Oh, it's actually the opposite. I did this math wrong. I'm going to change it. So their actual score minus their predicted score. There we go. So this school right here, Harrowbud Elementary, they scored 319 points higher than they should have. This school right here, 246 points higher than they should have. Higgs Carter, 228 points higher than they should have. Now, this doesn't necessarily mean they were cheating, right? Maybe a lot of schools scored 300 points higher or 300 points lower. Maybe that's normal. Right now is the one place where statistics is actually going to matter. We are going to do the standard deviation of the error. And you're like, what? And I'm like, don't worry. What I'm saying is, I'm saying, how strange is it that this number is 300? How strange is it that this number is 156? And if we go look at this code, a bigger number inside of here in the standard deviation means it's stranger. Usually over 3 means something weird is happening here. So all of these schools, their scores seem a little bit suspicious, whether it's they scored too high or they scored too low, just because that standard deviation is high there. And you're like, okay, well, we have a list of schools that seem suspicious. Do we just go out and say, Harrowbud Elementary School cheated? They are all cheaters. Toccoa Elementary, they're all cheaters too. No, as I've said before, this is all about being a journalist. This is all about doing investigative journalism. And so what we do is we look at these numbers and we know these schools seem suspicious. Let's go look at them. Let's go see what might have changed about the schools between those 2 years, see whether they fired anybody, see whether they know anything. Time for our investigation. If we actually open up the story, we can see how they wrote about this. They do not talk about standard deviation or difference in scores until very close to the bottom. What they do is they translate this into something that normal people will understand. Not that you understand what a standard deviation is. Do I understand what a standard deviation is? Who knows? If it's higher, it's stranger. If it's really low, it's also stranger, right? Right here. 3 standard deviations means something is strange here. That's literally it. We have a scientist saying, if you see big swings in the numbers, it seems like it's unusual. That's literally the way that they describe it. When they are attempting to explain the fact that it was suspicious, they will say in 3rd grade, they were in the bottom 4% of the state in reading. But the 4th graders, oddly, are the 2nd highest scores in the state. So that seems remarkably suspicious. So a lot of times, even if you're doing a linear regression to kind of understand, are there things that are unusual in this data set, you don't actually put it in the final product. You're simply using it as an investigative tool to track down data points that you might want to investigate a little bit more. So for example, if someone has a really boring job and they make a lot of money, maybe you should investigate that. If they have a very fancy job, but they make a very little bit amount of money, maybe that's kind of unusual. It's just a lead for you to do more research, not a way for you to say, these people are cheating. All right, let's do some logistic regression. So logistic regression is commonly used to deal with bias and to understand when bias happens in the world around us. Generally in the United States, we have a lot of data about race and gender, and all of these stories are about basically discrimination based on race or gender. So the idea might be, this first one here is, when you are speeding, you can get pulled over when you're driving, and you might get a ticket, or you might just get a warning, right? The cop might say, it's okay, go on with your day. Or they might say, we're going to give you a ticket. What affects this? How fast you're going, whether you live in the state or the town that the cop is from. Also, maybe things like gender or your race. What kind of effect do these things have? That's what we're going to investigate. Reveal did a great giant piece about mortgage lending bias, where if you look at people who are attempting to get mortgages to buy homes, you can say, hey, I want to get a mortgage. Here's where I live. Here's how much money I make. Here's some information about myself. And due to the government being problematic, or not government, banks being problematic in the past, they actually have to release all the data about whether they gave people mortgages or not. So what will happen is, or what Reveal did, is they went through this data and they said, based on all of this information, what kind of effect does being a woman have on you getting a mortgage? What kind of effect does you being rich have on you getting a mortgage? What kind of effect does your race have on getting a mortgage? And so yes, being richer makes it easier to get a mortgage, but additionally, it turns out that race does also play a factor. And Reuters did a really good piece about asylum applications in the US, and how one of the major things that will determine whether you are granted asylum in the United States is not how good your story is not where you're from, but rather the judge who is hearing your case. So if you get the friendly judge, you get asylum. If you get the mean judge, you don't get asylum. And so what they did was they trained a model by feeding it all of this information, where someone's from, things about their story, what judge they had, and then the output. Did they get granted asylum or not? So they said, machine, please learn about all of these things. Learn, make a little model of what it is like to be granted asylum or not granted asylum. And then you can look at it and say, what is important to this model? Is it important whether you're wealthy? Is it important whether you're Black? Is it important whether you're from Puerto Rico? So let's run some code and make this work. So I'm going to open the Run This Notebook on Google Colab. I'm going to shift enter here. We're going to be doing the speeding ticket one this time, because it's very, very simple. It's a pretty solid one too. I also simplified it a little bit for us. But if you want to read the original piece, it's from 2004. It's on a really ugly website, but it still exists. So I'm going to download this data here. I'm going to read the data in. So if we look at the data, you can have a type. Type is the kind of ticket that you got. Did you get a ticket or did you get a warning? So it's about 84,000 people got tickets and about 82,000 people got warnings. And for each one of those people, it says, are you a minority? Are you Black? Are you Asian, Hispanic, male or female? Did you get stopped at night? How fast were you going? How old are you? All these sorts of things that can go into our model. Because if we think about what affects whether you get a ticket or not, yes, whether you're going incredibly fast definitely matters. Whether you're speeding in a place that's a 25-mile-an-hour zone versus a 65-mile-an-hour zone probably also matters. And things like, are you a woman? What race are you? Are you someone from out of state? A lot of places in the United States, there's small towns that make a lot of money by pulling people over and giving you tickets for going like 1 mile over the speed limit. And they just do that because they know you're not from that town and they want to make some money. So if you didn't know how logistic regression works, what you might do is look at this and say, let's put people into groups based on whether they're a minority or whether they're white. So that's the M and the W, and whether they got a ticket or whether they got a warning. And you can say, okay, for people who are minorities, about 66% of the time they got a ticket and about 44% of the time they got a warning. Whereas for people who are white, it's about 49% ticket, 50% warning. So you look at that and you're like, it seems more likely to me, or it seems more likely that if a minority gets pulled over, they're going to get a ticket. This is always the first step in your regression. The second step is when someone says, yeah, but I think minorities just drive faster. Minorities drive faster all the time. And you say, that's not true. No, everyone's speeding at the same rate all the time. And they say, no, this doesn't take into account how fast the person is going. Or we're in Massachusetts. Everyone who's a minority is from out of town. So we're just giving more tickets to people from out of town. It's not because they're Black, it's because they're from out of town. And so when you get to that sort of situation where you have one value that you think is important, but there's all these other confounding factors or all these other things you want to control for, that's where logistic regression comes into play. So what we're going to do is I'm going to take this ticketed column, and instead of being T or W, I'm going to turn it into a 1 or a 0. And then I'm going to say, hey, let's see whether being ticketed, what effect it has, your sex, whether you're a minority, how old you are, how fast you're going over the speed limit, whether you're from in town or out of town, whether you're from in state or out of state, and whether it's day or night. It does a bunch of magic. It gives you a bunch of results. These results are never what you care about. You can care, let's say you can't care about it. If you do want to care about any of these numbers to see like how real this is, read investigate.ai because I have a much longer summary there. And then we get down here and we say, okay, this odds ratio here is how likely it is for you to get a ticket. So if you are a man, you are about 40% more likely to get a ticket than a woman. These are actually, it's pretty difficult to read this. So what I'm going to do is I'm going to do something a little bit different down here where I say, so right here it says, if you're a man, you're technically 38.5% more likely to get a ticket. But compared to what? Compared to being a woman. This one right here says, if you are white, you are 67% as likely to get a ticket as compared to if you are a minority. I find that kind of hard to read, kind of hard to understand. So what I do is I do something called a treatment, which just says, let's base this on like white people are the default, females are the default, being in town or being in state is the default. So right here, if we keep running some code, we will get to the point where I can say, okay, if you're a man, you are 48% more likely, no, if you are a minority, you're 48% more likely to get a ticket. Controlling for your gender, controlling for whether you're in town, out of state, day, night, age, or miles per hour over. So a big question you'll have when you are creating these regressions is like, what actually matters, right? Up here, I just said, hey, people who are minorities get tickets more likely than people who are white. And then someone said, oh, but what if they're male or female? What if they're in state or out of state? What about how fast they were going? People will always argue about what you should include in your model, what things you should pay attention to. And probably the best thing you can do, sometimes you will publish these numbers down here, but more often what you will do is you will take this information to several different statisticians. You'll probably, you'll find someone who's either a sociologist who works in this field or who is a statistician at like a college nearby. And you'll say, hey, can you look at my analysis and tell me whether it makes sense or not, or what I should change? And when I was talking to the people from Reveal who were doing the mortgage loan bias thing, they talked to 3 different statisticians and they all had different opinions and they just tried to make them fight each other. And so with stats, it's definitely more of an art than a science. And so nothing you do is ever going to be perfect, which is why I say as journalists, you shouldn't stress about learning all of the details. Just get to the point where like I cut and pasted some code. I think it looks like people who are minorities are ticketed a lot more. It looks like men are ticketed a lot more. It looks like people from out of state are ticketed a lot more. It looks like old people are ticketed less, things like that. You can take this to a statistician and they will give you their opinion on it. They'll probably be excited to give an opinion about it. If you just brought them the data and said, do an analysis, their response would be no. But if you bring them a completed analysis, they'll definitely give you suggestions about what to pay attention to, things you might not have thought of, whether you should be using a different kind of regression. So this is what you're looking for if you're going for bias, logistic regression. Now, finally, my favorite, because it's the easiest, is classification. So I talked about BuzzFeed and LA Times already, right? It's the idea that we have a bunch of planes that look like, or we have a bunch of planes that we know are spy planes or not spy planes. Can we train a model to determine whether something is a spy plane or isn't? We have a bunch of crimes that are either serious crimes or non-serious crimes. Can we train a model to differentiate between the two? The piece that I usually have people do in class is about, it's from the Washington Post here, I'll click the normal one. It's about reviews on the App Store for random chat apps, where I can open it up and chat to a random person. And the idea is like, are people leaving a bunch of comments where they say, I'm being bullied, or I keep getting sent, you know, unwanted sexual images or anything like that. And so what you do is you download, you know, 30,000 of them, and you read 100 of them, and then mark like, yes, I'm interested in this. Yes, I'm interested in this. No, I'm not interested in this. No, I'm not interested in this. And then you train a model based on those 100 that you read. And then you say, model, please go read the other ones and classify them as to whether they're interesting or not interesting to me. Now, the thing that we're going to cover is not a Washington Post story, but a story that one of my students did in 2 weeks. 2 weeks, like 3 months after she learned Python, her second semester at the journalism school at Columbia. And what she did was she was looking at therapy app reviews, where when people were in the US, people love to get therapy on apps these days because our medical system is awful and therapy is awful and COVID, and you just want to sit inside all day. So what happens is people say, hey, I was charged too much money, or my therapist was terrible, or my therapist didn't respond. And she downloaded thousands and thousands of reviews, but she didn't want to read all of them. So what she did was she read about 180, I think. And she said, yes, this one is about an unfair charge and an unresponsive therapist, but not about a bad therapist. This one is about an unfair charge, not an unfair charge, not an unresponsive therapist, not a bad therapist. And she just went through 180 of them. She just did this in Google Sheets. She put this in one column, this in another column, created 3 new columns and just labeled them 0, 1, 0, 1, yes or no, yes or no. And so what we can do is I can say, okay, we are going to take all of the ones that she has labeled, all of the ones that are unfair charges, whether yes, they're unfair charges or not unfair charges. We're going to separate those out. And then we're going to have a bunch where we're not sure whether they're about unfair charges or not. Maybe they are, maybe they're not. We don't want to read them. It's too much to read. And so we have about 2,500 that we haven't read and 180 that we have read. And then we're going to say, hey, computer, take all of the text that is in these reviews and just count all the words. Count all the words that are inside of them. I'm going to do this not as slowly as I normally do, but it says, okay, is the word wouldn't inside of this one? Yes. The word 30 is inside of this one. The word account is inside of this one. And the text here looks kind of weird. And that's because it's combining different words that are kind of similar. But the idea is this is 180 different reviews. And for every review, it's counting the words inside of it. And then I say, okay, based on those word counts, based on the number of times refund showed up or charge showed up or anything showed up, we are going to feed all of this information to a machine and see whether that machine thinks yes, or teach the machine to differentiate between ones that are not about unfair charges or ones that are about unfair charges. So I'm saying, hey, feed in all those word counts that we just did, and then use it to predict whether it should be or whether it is about an unfair charge. Now, we just kind of threw it at the machine and we don't really know how the machine is working. So one thing I like to do is look at the words that it thinks are important to make sure it makes sense. So if we install this fun library called ELI5, remember before I was saying neural networks, fancy artificial intelligence, difficult to understand, whereas scikit-learn, what I'm about to teach you, is more easy to understand. If we run this code right here, it says, this is what's important. The word refund, really, really important. The word charge, less important. Bill, little less important. Company, little less important. And it goes through all the words to tell you whether it's an important word or not an important word. And it really helps you be able to understand what is this machine using in order to see, yes, this is an unfair charge, or no, this is not an unfair charge. We could have done this research manually. If we knew we were looking for unfair charges, obviously, we could have just searched through our data for where it says refund, for where it says charge, for where it says bill, and we would probably find like 99% of these. So yes, oftentimes when you're doing this sort of classification analysis, you could kind of do it manually too. But sometimes you're just like, I want the machine to do it. It's a little bit easier. It's fine. So what we're going to do is we're going to say, hey, take all of these unlabeled ones, all of the reviews that we have not read, and make predictions. Predict based on the words in them whether they are about unfair charges or not. So let's see. This one right here, it predicted that it is about an unfair charge. You read this and you're like, yeah, it looks like this is about an unfair charge. You look at the second one, it is also about an unfair charge. You keep reading and it says, oh, was going to get a refund, but it didn't happen. And as you go through here, let's see, this one is not about an unfair charge. And if you read it, you're like, oh, it's about matching me to a therapist. So by running those calculations, we can now just say, hey, give me all of the ones that are probably about being predicted about unfair charges, and I'll just read them. There's another column that we added called predicted proba. The higher this number is, the more likely it is to be an unfair charge, whereas the lower it is, the less likely it is. So one thing we can do is just take the 1,000 most likely ones about unfair charges and save it. Or we could do something like, even if we don't trust this 100%, right? We know that our algorithm's not perfect, but we can just roughly say, based on all of these different apps, which ones are more likely to have unfair charges written about in the reviews. And it looks like Cerebral's the one. Now, I don't want to talk about testing the model. You can look at it if you want to, because I want to say, take our final moment and say, this student, as I said before, she did this in 2 weeks for a class project. She had never done machine learning before. She had just learned about classification. I don't even know if I taught it in class. I think she just read my website and learned how to do it. And she had learned Python like 3 months earlier. So she wrote this piece about it. And she, classified things, made some charts. But the thing that's the most exciting is a couple days ago, maybe even yesterday, she published an actual story based on this research. So in the way that I say, you're not doing this in order to simply like make a chart and say, this is how it is. It's about insurance or it's about unfair charges, right? She used that filter and she started to investigate more and then did a big piece about Cerebral and about how it's doing well or not doing well, or the bad things that it's doing with all of its clients. So that is here. Let me throw up my final slide just so I can. This is going to be not very exciting because it's just my links and everything, but might as well show you. Okay, so if you want any of that code, if you want any of those links, if you want to send me an email or scream at me on Twitter or anything like that, that is all of my information. So thank all of you for listening to me, and let's do some Q&A now. I'm excited.
Okay, thank you, Soma, for the demo. It's interesting to see how models and also machine learning can help the journalists to find different patterns, or like what you said, outliers within the data sets. And now we already have like some questions in our chat box. The first one is related with what kind of skills do journalists need to learn about machine learning at the beginner level?
Yeah, so I think that when you are learning machine learning at the beginner level, there are many different places you can come in at. I personally think that if you go start with the classification project, that's probably the easiest thing that you can do. Because even though it had a little bit of extra code in there, conceptually, it's easy to understand. You don't need to think about statistics at all. It's just counting words. And so if you wanted to do that, you could do that in Python. You could, click that link and run that Google Colab notebook and upload your own data set. That would be fine. You could also look at that tool that I showed before for a second, vertex.ai, which is that tool that Google produced. And so when you use vertex.ai, you just go through a process of dragging and dropping things, selecting columns. It's not that easy to use, I'm going to be honest. But just knowing the concept of classification allows you to use these easy to use tools if you're not comfortable using a programming language like Python.
Okay, so we will move to the next questions. The first one from Anissa, and then the next questions will be from Himatul Ulya. So Himatul asks, thanks Jonathan for the explanations. I'm very enlightened by the statement that journalists are not statisticians. I think sometimes we got scared when looking at the model, but then when you say it like, don't worry, it's not your job. And then, some of us feel, okay, that probably can do this machine learning things. And so the question is, can the use of AI in newsrooms change the ethics of journalism? And what is the ideal practice of using AI in newsrooms?
Yeah, so I think that it's difficult because it often turns into a question of what are you using AI for? So there are times where, if it's just investigative, I think that that's an easy way where it's the same as someone giving you a suggestion to look at something or investigate down a path. If you start making statements, though, based on something that you didn't read, but a computer read for you, that gets more difficult. For example, the Washington Post article that I talked about before, in their article, they say 33.4% of reviews of this app mention unwanted sexual behavior, or some number like that. And if they didn't go through and read every single one of those reviews and flag it as either about that or not about that, I don't think that they should be trusting their machine learning algorithm to give such a specific number. They might be able to say more than a quarter or something that's a little more wishy-washy, but I just think that if you are telling a computer to do the work for you, you have to make sure that you're not trusting it as much as you would trust a person. It's about as trustworthy as a very new intern that has never had a job before. It's not necessary, it's excited to do a lot of work for you. It will work on the weekend, it will work overnight, but it's not necessarily always going to be correct. So that's the thing to really pay attention to there. And I think that investigative is probably my favorite use of AI in newsrooms, but it can be used. The New York Times had a bot where you could text a picture of people around, like people in government in Washington, D.C. to this bot, and it would text you back who they were because it would do facial recognition on them. And so that's not really investigative. That's not really on the business side, but it's just, if you can do it with AI, why not?
Okay, so we're going to move to the next questions from Azaria. And she said, hi, really great insight. My questions though, is it necessary has to be the journalist itself who does the machine learning and building the model, probably Soma, or is it okay if the computation part, because it seems very complicated, she said, is done by another role or persons, and what is the best practices out there? Maybe if we related it to the practice of the newsroom or media based on your observation so far.
Yeah, so oftentimes a lot of these case studies that I put on investigate.ai are the first time someone has ever worked with machine learning. So whether it's regression, linear regression, logistic regression, classification, I interview these people and they say, I have never done this before. I talked to my editor and she said, oh, talk to my friend. This seems like a problem that's similar to something that they did. Oftentimes what will happen is you will partner with someone who is more of a data scientist to do the analysis and talk through it. The Washington Post piece about app reviews was done by someone who was on the business side, he was the person who made sure that like people signed up for the newsletter and made sure like people, didn't unsubscribe and things like that. And he was very excited to be able to do some journalistic work. But it really does have to be a back and forth between the journalist and the person who's more of a statistician or a data scientist, just because the things that journalists care about are not always the same as the things that a data scientist might care about. Additionally, the way in which journalists love to ask questions really helps the data scientist kind of make their model better. For example, when we were looking at the Boston Globe one and we were thinking, what are the things that might make someone get a ticket or not get a ticket? If you're a data scientist who's not thinking too hard, you might just throw a couple columns in there and not really care. But the journalist's job is to come in and say, no, I think maybe we should add this one and the other one. Also, the journalist's job will be to take it outside of the news organization and maybe interview a subject matter expert and see whether they agree with the analysis.
So it's related with the verifications process, yeah, verifications, and also to confirm again whether the finding is, related with the reality out there or not. Okay, now we're gonna move to another question. So it's from Lydia. How much a newsroom should invest in terms of human resources and technology if they wanted to develop machine learning for news?
I think that the most difficult part is this, because as a newsroom, it is difficult to commit resources to something that you don't see an immediate return on. It's much more likely that they will use machine learning to have more people sign up for the newsletter than some sort of investigation. So most of the people that I talked to, they didn't actually have an official machine learning team, or their boss wasn't guiding them through machine learning or anything like that. They just said, in order to do the best job on this investigation, I should probably pick up some of these skills. And so this is an example where even though my one student did that project in 2 weeks, I think the best use case for machine learning is when you have a lot of different documents and you have a long time where your boss says, read all of these documents and find the interesting things inside of it. So you have a little bit of extra room in there where maybe if you teach yourself how to use machine learning to read those documents for you, it saves you time in the long run, because it's going to take months to do that project anyway, maybe. So just making sure that instead of having the newsroom dedicate effort to machine learning, it's really usually you finding a place where you can sneak it in if you have enough time.
Okay, so usually it does really need extensive time and analysis for when doing the analysis by the machine learning, yes, Soma.
I would say that it's less that it always requires a long time, but more that if it doesn't work immediately, it might take a really long time. And if your editor says, I need this by Friday, it's probably not a good time to try to learn something new. But if they say, I need this in December, you have a little bit of extra flexible time in there to learn something new.
But if we partner, for example, with data scientists to help us build the model, like as journalists, we tell that, oh, we want to find some patterns from this data set. Can you make a model based on that, questions like that? How usually, how long for, like a data scientist or someone to build the model, like, and then do the analysis, building based on the questions built by the journalist?
Yeah, usually a lot of the difficulty in building a model is finding all of the data. For example, the Boston Globe traffic tickets, we needed to know the people who got a ticket and the people who got a warning. And the government used to only release people who got tickets, but then they accidentally also released the warning one. And that's the only reason why they could do that analysis, is because the government made a mistake in the data it was releasing. And so finding data and cleaning data is really the most difficult part, I would say, and then adding in a little bit of subject matter expertise. So if you have the data and then you can approach a data scientist, I think that's probably a better way to approach it. If you can think about what the inputs are to the model and then say, here's what my question is, can you, they might be able to do it in a couple hours. It depends on how good they are, how used to it, the kinds of techniques they use, because every data scientist does things a little differently. Especially these days, they might be a more like artificial intelligence neural network person, which is different. But yeah, it depends on who you're working with, absolutely.
Okay, so we have also another questions coming. Can machine learning be used for fact checking?
So I know the answer to this is absolutely yes, but I don't know the details of it. I know that the past 2 or 3 years, there's been a lot of advancement in computers understanding things and being able to analyze text in a way that they couldn't before. And I know that there have been a lot of grants given out to organizations who are researching disinformation and misinformation. And they have systems that can supposedly read text, identify factual statements, and see whether they are probably true or probably not. I unfortunately don't have much in front of me that I can tell you, but I do know if you look up artificial intelligence for fact checking, you can definitely find some good things to read about that.
Okay, thank you so much. And now we have another questions from Fabio Nainggolan. And he asks, thank you, Mr. Soma. I wonder if the investigative AI can be hacked by a stranger who can change the data at any time, because I think double security is very important for journalists.
Yeah, so I think that with investigative journalism, data security is always going to be a big issue here. I would say that usually if someone is going to hack you and do something with your data, they're probably mostly just going to spy on you instead of edit your data. Maybe they'll delete your data and then you'll have to get it again. But I think that it would be rare for them to change the data just enough for it to cause some sort of error, some other sort of output. I will say that if we start talking about more conceptual machine learning or more like self-driving car, artificial intelligence, this is actually a big ongoing area of research, because there's the idea that maybe if I go out in the world and I put up some really special sign somewhere and then the car sees it, you can make the car do something crazy because you hacked the initial data or hacked the model. So in theory, there are attacks where something like that could happen. But I think in practice, as a journalist, it's going to be a little bit more rare.
Okay. So for the next questions, I'm actually curious about when you say it like the machine learning model can actually be not sensible to gender and also to race. So what makes a model for machine learning can be not sensible to gender and, and race also, and how to avoid that when Newsroom trying to build a model for their analysis?
Yeah, I think that it's less of an issue when a newsroom is trying to build a model. Usually when you see models that are biased according to race or gender or anything like that, they're ones being used by big companies that have a lot of information. Just because it's rare that okay, here's how we're going to do this. When you are a journalist using machine learning, you're usually looking backwards. You're looking backwards and saying, this is an example of how the world is. Why is it that way? Or why is it different from that way? So the linear regression, we looked at test scores that already happened. When we are looking at the speeding tickets, we're looking at tickets that have already been given. When we are looking at the classification one, we're looking at reviews that have already been written. The problem comes when we start to look into the future. So for example, ProPublica had a piece about a system called Compass that was looking at people who had committed crimes, and it would say whether they were likely to commit more crimes in the future. And as a result of that score, you would put them back in jail or not put them back in jail, basically. And so when you look at that system, it turned out that that system was biased in several ways. But the issue wasn't, the issue there was they were taking the system and then doing something with it that had to do with the future. Same thing with Amazon. Amazon was looking at people's resumes and saying, based on this score, we are going to either interview you or not interview you. And so luckily, journalists are mostly just looking in the past to see how things were and find patterns and investigate those patterns.
Okay, now I would like to ask questions related to previously you said like the most important thing is actually to build the model or doing the machine learning analysis is like to find the data, finding the right data and also to clean the data. So how to build or sensors to spot easily which data actually can be used for machine learning analysis and which are not, like maybe give some insight.
It's very difficult. It's very difficult. I think that for me, the way that I started to learn what data sets would be better for machine learning is really when I started to do research for investigate.ai. And I started to see these patterns about what the data sets looked like. They were usually bigger data sets. They usually had some sort of outcome about whether something happened or something didn't happen. You got a ticket, you didn't get a ticket. You got a mortgage, you didn't get a mortgage. This is about unfair charges or it's not about unfair charges. Things like that are kind of tips that maybe this data set would be useful with machine learning. But I'll also say, this is, my students love to just find data sets and say, I'm going to analyze this data set. It's going to be great. But I never recommend starting from that point. I recommend starting from having an idea and wanting to do an investigation and wanting to start looking at what might be able to give you data or information. So when you start to investigate a field or a topic and you collect all of these data sets, it's when you start to go through them, and you're like, oh, instead of me going through every single one of these, this project seems similar to this one I read about already. Maybe I can use machine learning on it. And so, yes, unfortunately, a lot of it is just becoming familiar with the kinds of stories that come out of it instead of just going down a checklist.
Okay, so unfortunately, we still have one more questions, but probably you can answer the last questions and giving a closing statement and a wrap up, because we only have like 1 more minute to wrap up.
Sure.
This is from Adi Octavianto. He asks, I read an article by Nicholas Diakopoulos on predictive journalism. Can you comment on that area? To what extent can journalists disclose the results of predictions and machine learning models to the public as news?
Yeah, so predictive models are awful and terrible because we saw what happens in the United States where we try to make predictions based on elections. So it's very difficult and it's not really journalist strengths. So along with everything else, I think using more machine learning to look backwards instead of look forwards and to use it for more investigative things. And if you want to make predictions, find someone who wrote an academic paper about it and interview them because they probably know more about it than you do too. The end.
Yeah, thank you. This is just right in time. Adi, if you want to ask more and then to get more answer from Soma, you can email soma@gs4571@columbia.edu and then get more discussions on that. And so thank you. I'm going to close this sessions and thank you everyone for participating in this sessions and then for throwing also a lot of questions to Soma. I think your presentations trigger a lot of questions and then curiosity from the participants here. Thank you so much, Soma, for being a speaker in the CJCI. So good morning, everyone. I'm going to close these sessions. Bye.
Thank you, Soma, and good luck with the renovation.
Thank you.
Bye.